Hey guys, for this enrichment lesson, you're going to first of all, you're going to need some paper to take some notes on. And secondly, you're going to need a calculator. And you're going to need a calculator that's scientific, preferably a graphing calculator. And so when you take your graphing calculator out, what I'd like you to do first with it is to hit the mode button and make sure that you're in degree mode. So you move down with the arrow, move over to degree, and hit enter to move that into degree mode. So that's the first thing I need you to do with your calculator. Then just hit second and then the mode button for quit, so you have a nice clear screen. So we'll be referring to the graphing calculator later. So what I'd like you to do next is make sure you have some notes out. And I will have given you a worksheet packet as well, which we will be referring to. I'm going to have you stop the notes periodically and go work on a few problems. And what we're going to work on for our enrichment lesson is the very tip of the iceberg of a field of mathematics that we call trigonometry. And trig stands for triangle, and metric stands for measure. And so it has to deal with measures on a triangle. And specifically, what we're going to work with today is only right triangles. You'll be studying this quite a bit in geometry, a little bit in algebra too, and then in pre-calculus, months are spent on the whole concept of trigonometry. It's a very powerful field of mathematics, and we're just going to hit the very tip of it today and tomorrow, but it's nice to get exposed to things ahead of time. It's on the ACT quite a bit, so that's always nice. So what we're going to do is I'm going to have you draw a right triangle today, because what we're doing is only going to apply to triangles that have a right angle. And notice that when my triangle has a right angle, it has two other angles, and I'm going to call this angle A and this angle B, and both of those angles are acute. And we're going to be working with side lengths on that right triangle, and we're also going to be working with angle measures in the right triangle. Now, up until the field of trigonometry, in order for you to find a missing side on a right triangle, you had to know two of the side lengths. Like you had to know that this was 3 and this was 4. And then maybe in linear algebra you learned something called the Pythagorean theorem, which said that a squared plus b squared equals c squared, and you could solve for c, or that missing side. What trigonometry allows us to do is find missing sides when we only know one of them. And also it allows us to find angle measures when we know the side lengths. So what was discovered historically is that the ratio, or the fractions of the side lengths, stay the same even as the triangle gets bigger. As long as this angle A here stays the same, then even if I make the triangle way bigger, as long as I keep A the same measure, the ratio, or the fraction of the side lengths, stays the same or stays constant. And when that discovery came about, they gave names to the ratios of the sides. I have 3 sides up here, and I'm going to classify them according to angle A. And what we do is we call this one across from the angle the opposite side. And you should be taking notes of this. So anytime we talk about opposite, you head straight across from the angle that you're working with. On a right triangle, the one across from the right angle, which is always the longest side, is always called the hypotenuse. No matter what angle I'm talking about in this triangle, the hypotenuse is locked in. It's always across from the right angle. This other side that's right next to angle A, you can see the hypotenuse and this bottom side here in green both touch or are adjacent to angle A. So we call that one the adjacent side. And then what we're going to do is we're going to use O for opposite, H for hypotenuse, and A for adjacent. And what we know is that the ratios of those sides will never change. As long as I keep A the same measure, when I do the opposite side divided by the adjacent side, even if I make a gigantic triangle, I'm going to get the same number. And so what we do is we have what we call some trig functions that, and it seems kind of weird, but once we get the language out of the way, it's actually really easy math. We've got something that we call the sine of angle A. We have something that we call the cosine of angle A. And we also have what we call the tangent of angle A. And these get abbreviated, and you'll see them on your calculator screen. They look like sin, but it's actually sine. You look right above your comma, and right above your parenthesis on your graphing calculator is something that looks like cos. It's actually cos for cosine. And then the next one in line is tan, which stands for tangent. And what these really are is just names. They're names that represent ratios of these sides. There's a nice acronym that's going to allow us to remember these. But when I talk about, and we'll do that in a minute, when I talk about the sine, which we abbreviate as SIN, of angle A, this is what I do. I go look at angle A, which is right here. The sine ratio is the ratio of the opposite side to the hypotenuse. So we say it's O over A. Now let's go put some numbers on there. Let's suppose that this length is 3, this length is 4, and the hypotenuse is 5. Then I would say that the sine of angle A is opposite over hypotenuse, which would be 4 over 5. And the sine ratio is 4/5. You'll see the power of that in a later part of this lesson, either today or tomorrow. For now, you just need to get the language down. That when it asks you for the sine of an angle, you're looking for the opposite side over the hypotenuse. So the next one that we have is the cosine of angle A. And when you're asked to work with the cosine, we say that's the side adjacent or right next to the angle over the hypotenuse. Or we say it's A over H. In my picture right here, when I'm looking at angle A right here, the adjacent side is 3, the hypotenuse is 5. So I'd say that ratio is 3:5, or 3/5. And last up, there's actually 3 more trig functions, but you're going to say those until probably pre-calculus or algebra 2. So the tangent of angle A is the ratio of the opposite side to the adjacent side, which we say is O over A. So in my picture, if I'm being asked for the tangent of angle A, I simply head across to the opposite side, which would be 4, and I look right next door to angle A, and you might say, well, there's 2 adjacent to it. But remember that that longest side across from the right angle is locked in as the hypotenuse. So my adjacent would be considered the 3. These are what we call trig ratios. Trig for triangle, ratio for fractions. So really what we've got here is 3 trig functions that have 3 ratios that go with them. And there's an acronym that makes it really easy to remember. We say sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. If you have a brother or a sister in a higher level math, or a parent who's proficient in higher levels of math, and if you were to ask them what's SOHCAHTOA, I guarantee you they'll know. It's a very common acronym in working with trigonometry. So what I would like to do is give you a little example right here, where I'm going to put a right triangle down. I'm going to put my right angle right here. I'm going to put an X at this angle and a Y over here at the vertex of that angle. And what I would like to do is put some side lengths on here. I'm going to say maybe put a 12 here and a 35 here and a 37 right here. So I've got the side lengths. I don't know the angles. I'm going to tell you how to find those in a later segment. But I've got the side lengths, and the first thing I want us to do is just get used to setting up the trig ratios. So if you were asked to find the sine of angle x, your eyes go to angle x, and you think so, ka, toa. You think so, which means you're going to do opposite over hypotenuse. So you go to angle x and you head across to the opposite, which is 12. And the hypotenuse is always across from the right angle, which is 37. It's as easy as that. Why is that helpful? You're going to find out in a bit. So the sine of angle x, we would say, is 12 over 37. What about the cosine of angle x? Again, I'm still then focusing on this angle. Cosine is adjacent over hypotenuse. So I will go adjacent or right next door, and there are two sides here right next door to angle x, but again 37 is universally called the hypotenuse because it's across from the right angle. So adjacent would be considered 35, and the hypotenuse is 37. How about the tangent of angle x? I would set up TOA, opposite over adjacent. So again, I'm looking at angle x. I'm heading across to the opposite side, which is 12. I'm going right next door to the adjacent side, which is 35. And those are what I would call my three trig ratios for angle x. Now, if I change the angle on you, and if I were to say, well, what's sine of y? Well, then things change, because now I'm looking at angle y as my reference angle. And so when I talk about, again, the sine being opposite over hypotenuse, hypotenuse is still 37, but now opposite of angle y is a 35. So I just have to be careful that I'm always looking at the angle they tell me to, and then I use this little acronym to set up the trig ratio. So what I'd like you to do right now is stop this video, and I would like you to go do 1 through 6 in the trig packet, and then check them with the key in the back. And it shouldn't take you very long because you're just going to be setting up the ratios. So stop and pause this, and then go do 1 through 6, and then come back when you're done with that, and we will continue with the next part of our trig lesson. All right, so part 2 of the trig lesson. For part 2, what we're going to discuss is doing them on your calculator. Part 2 is not going to take us very long. If your calculator is in degree mode, it's been programmed with all the angles in it for you to be able to come up with a decimal for sine, cosine, tangent. So if I were to ask you what is the sine of 42 degrees? Now if you had the triangle sitting there and you could see the sides, you would set up the ratio of the opposite side over the hypotenuse. And no matter how big I make the triangle, so let's pretend this is 42 degrees, and then let me make a lot bigger one, so everything gets proportionally bigger, and still keep that at 42 degrees. Because it's proportional, what I've got here is it doesn't matter how big the triangle is. The opposite side over the hypotenuse for the big one and for the little one is the exact same ratio. And I can make my calculator give me the decimal form of that ratio. So take out your calculator, and what you do is you just go and you hit, so let's go to the calculator. Again, hopefully you already put it in degree mode. To use your calculator, you just go like this. I would like to know the sine of 42 degrees, and just hit enter. And you'll get 0.669. Go ahead and round maybe to 3 decimal places, that's fine. What that means is, for any 42 degree angle of a right triangle, when I divide the opposite side by the hypotenuse, I'll always get 0.669. Why do I care about that? It's coming up in the word problems. You'll see how applicable this is in just a minute. But I have to get you the language down and the calculator use down before we can apply it to something that actually matters. So again, if you were asked what's the cosine of 39 degrees, you just go ahead and enter it. And my calculator will tell me that no matter for what right triangle I have, if there's a 39 degree angle in it, then when I divide adjacent, because it's so ka, so cosine would be a over h. If I divide the adjacent side by the hypotenuse, I'll always get 0.777. Let's try tangent of 45 degrees, and then I'm going to discuss why this makes sense. Notice I get a 1. All right, let's show you why you get a 1 for that. So again, on this one, when we went to our calculator, we got 0.66 something, I believe. So you just entered on your calculator. I just lastly had you enter tangent of 45 degrees, and it said it was a 1. Let's discuss why that makes sense if you understand the whole ratio thing. When I have a right triangle, and one of the angles is 45 degrees, then because the angles in a triangle add up to 180, the other angle's also 45 degrees. Or you can think there's 90 degrees left that needs to get shared equally. So what I also know is that when I have a 45 degree angle in a right triangle, it means that right triangle was half of a square, which means that these sides are equal. So no matter what they are, all right, let's pretend they were 10. If that's 10, that's 10. So when I'm asking my calculator to do the tangent, TOA, of 45 degrees, so tangent 45 degrees, I'm asking it to do the opposite over adjacent ratio. And for a 45 degree angle, because it's half a square, these sides would always be the same. That's why my calculator is giving me a 1 for tangent of 45 degrees. So what I'd like you to do right now is stop the video and go use your calculator for 7 through 12, just to get used to working your calculator. So pause this, go take about 2-3 minutes to punch 7 through 12 into your calculator. Let's round it to say 3 decimal places. And then when you come back to the video, now we're going to start applying this so we can see what it's used for. And then in the last segment, we're going to throw some word problems in. So we're back. And the next thing we're going to discuss, part C. So part A was just SOHCAHTOA. What are the ratios? What does sine mean? It means opposite over hypotenuse. What does cosine mean? It means adjacent over hypotenuse. What does tangent mean? It means opposite over adjacent. And we learned how to set up those ratios. In part B, we learned how to use our calculator to get the decimal for sine, cosine, and tangent. And now what we're going to do is we're going to use our trig ratios, and you should be taking notes on this. It would be very beneficial for you to have some exposure to this before geometry, but if not, it's not that big a deal, but it's nice to get a little taste. So we're going to use the trig ratios, again that's sine, cosine, and tangent, to find missing sides on a right triangle. It has to be a right triangle for this. Missing sides on a right triangle. So what I'm going to go do is I'm going to go draw just a standard right triangle that looks all nice like this. I'm going to go slowly through this process of how do we use trigonometry to find missing sides. And then I'm going to put this right here. And I'm going to say, oh, that looks like it's maybe 40 degrees. And I'm going to say I don't know how high this is. And I'm going to say I do know that this is maybe 15 long. The question's going to be, how can I have only one side of a right triangle and be able to figure out the other sides? And the answer is you can't unless you know one of the angles. Now if I know the angles, I can actually go figure out what x is. So let's go see how we do this. The first thing you do is you classify in your head or on paper the two sides you're working with as opposite, adjacent, hypotenuse. So let's go see what I mean by that. When I'm looking at this 40-degree angle, the x that I'm looking for is opposite it. The 15 that they gave me is the hypotenuse because it's across from the right angle. So in this problem, I know I'm dealing with O and H of these three. Keep that in mind. Once I've decided that, I select either the sine, cosine, or tangent trig function to use on this problem. Now because I called this opposite and this the hypotenuse, what that means is I'm going to be using the sine function. So for number 3, what I'm going to do is I am going to set up the trig ratio that goes with sine, cosine, or tangent. And again, I selected sine because I'm working with opposite and hypotenuse. If the 15 had been down here on the bottom, then I'd be dealing with opposite and adjacent. And I'd be working with TOA, or the tangent function. So I'm just going to go like this. This is what I know. I know that the sine of the angle that I'm looking at gives me the ratio of the opposite side to the hypotenuse. I also know that the opposite side is the one I'm looking for, and I know that the hypotenuse is 15. So I need to solve this for x, which means all I really need to do is get this sine 40 degrees right here. This is a number. It's kind of like if I said 10 is equal to x over 2 and I'm looking for x. I would double both sides and get x is 20. This is what I'm going to do here as well. I know that when I divide by 15, I get sine 40. So to undo division, I'm going to multiply both sides by 15, and that'll cancel out. So what I get is 15 times the sine of 40 degrees is equal to my missing side length. Now I go to my calculator. So I'll find my calculator here, and I enter that. So let's clear off what we've got. We said that x is equal to 15, so you just go ahead and enter it. You don't even need to hit times, you can just hit sine. And I had a 40-degree angle. Hit the 0 here, and you just hit enter. My missing side length is about 9.6. So we'd say 9.6 is about the length of my missing side. It's as easy as that. Its power you can't see yet because we're not in the word problems. However, you can kind of maybe anticipate how this might be used. For example, if I had an airplane, this isn't a very nice airplane, that had maybe a certain what we call angle of descent, and I knew that I had that angle gadget in my airplane set to maybe 37 degrees. And if I knew that I was maybe 1,000 feet off the ground, I could figure out the distance to when I'm going to land, or I could figure out the horizontal distance just by using some trigonometry. Maybe I know I need a wheelchair ramp that by OSHA guidelines or whatever, by law, has to have an incline less than 8 degrees. And maybe I know that I wanted to reach a door that's 3 feet off the ground, and I know that I have to keep this at 8 degrees. Well then, how long of a ramp do I build? A little bit of trigonometry there. It's also used to find the heights of things that are incredibly high. If I want to know how tall a really tall building is, I don't go to the top and drop a tape measure down. I don't. What they do is they measure what we call the angle of inclination up to the top. So this gets measured right here. Maybe it was 67 degrees. Sometimes on the highway, you've probably seen those little yellow tripods with people out there. A lot of times what those do is they measure angles because it's way easier to work with the angles than things that are incredibly long or incredibly tall. So if I know I've walked away from this really tall building, maybe 10 feet, and I'm looking up at an angle of 67 degrees, I can figure out how tall it is. How? With this process. Watch. Let's go do it. So I've walked away 10 feet, which with this angle measure is my adjacent side, and I'm looking for the height of this building, which according to this angle measure is the opposite side. Which trig function deals with opposite and adjacent? TOA. So I say this, I know the tangent of my angle is equal to opposite over adjacent. I know the tangent of my angle would be the height of that building over how far I walked away. So I'm actually not measuring the height of the building. I'm walking away and I'm looking up. And I can tell you exactly how tall that is. Because in order for me to get at this x, I simply take both sides and multiply it by 10. And I get 10 times the tangent of 67 degrees is equal to x. And I go to my calculator, which already has all the trig functions programmed in, and I simply say 10. Sorry, it's finicky. 10 times the tangent of, and I think it was 67 degrees, and then I just hit enter. And voila, the height of the building is 23.6 feet tall. And so you can kind of see what's coming in with that. This was, I think I said 23.6 feet is about the height of my building. I never even had to measure it. All I had to do was walk away and have an angle measuring device and look up. I can tell you exactly how tall it is. We could do that with a flagpole out in the parking lot. You could just simply go out, walk away from it, measure the angle of inclination that you're looking up, and you'd be able to tell me how tall that thing is. Wouldn't have to climb to the top and use a tape measure. So what I'd like you to do right now is go into that packet, and we're going to now work with numbers 13 through, there's the rest of it here. We're going to work with 13 through 18, and then that'll be it for this segment, and I'll do another segment on working with the angle measures later. So for 13 through 18, you're going to be finding the missing side. You're going to be rounding to the nearest tenth. And the one I would like to do with you is number 17, because something different happens in that one, so I want to make sure we know how to tackle that. So on number 17, I've got my right angle that looks like this. I've got the 40 degrees here in the top right. I've got an unknown side and a given side. My process goes like this. I classify those two sides. I classify the one I'm looking for in reference to the angle and the one they gave me. Notice they did not give me the hypotenuse. So I've been looking for the adjacent side when they gave me the one opposite it. So I've got my SOHCAHTOA that will help me determine which trig function to use. I'm dealing with opposite and adjacent. This would be a tangent problem. So I set up my ratio and I say the tangent of my 40-degree angle is equal to opposite over adjacent. The tangent of my 40-degree angle is equal to opposite over adjacent. Now this one's different than the last two because my variable is on the bottom. But all you're going to do differently is you're going to get it off the bottom. To undo division by x, you're going to multiply by x. And what you're going to get is x times the tangent of 40 degrees is equal to 20. Keep in mind, this is a number. It's in your, you could go change it to a decimal on your calculator right now, but instead of rounding twice, we only want to round once. So we're going to use that on our calculator. How do I solve something like x times 2 equals 10? I divide both sides by 2 to get that to cancel. That's exactly what I'm going to do here. I'm going to divide both sides by the tangent of 40 degrees, which is a number. Right? And I go like that. And it cancels off. And so I'm going to go to my calculator and do 20 divided by tangent of 40, and I'll get that missing side length. So 20 divided by tan 40 on my calculator looks like this. 20 divided by tangent 40. And you don't need to close the parentheses if you don't want to. Your calculator does not care since it's the last thing you've entered, but I like it to look nice. So that missing side length would be about 23.8. So x would be about 23.8. So I would like you to continue working with 13 through 18. When that's done, you'll log on to the second video, which is going to be, well, can I use this to find missing angles? if I know the sides? And the answer is yes. So our next task is not going to be to find a missing side, but we're going to try to figure out what the angles are. And so you'll have to bring up the trig part 2 video.